Hello everyone, this is Mrs. Hennessy. I'm here to get us started with our new unit, Unit 5. This video should mainly be review, so I hope that you find this work to be very basic. So here's a little review that we're going to need. All of these things you should know. We've talked about them in Unit 1. If you would read this over, variable, term, like terms, monomial, binomial, polynomial, and constant. All of these things you should be familiar with. But if you're not, the vocab is right here for you. Feel free to pause and read this over. There will be times when you will be asked to add polynomials. In these examples, they use the word sum. What is the sum of? And we should all know that sum means add. Now, to do this, I'm just going to rewrite these polynomials, but I'm going to keep them grouped. So this is one of them, and this is the other. Remember, when you add, order doesn't matter. So I'm just copying these down. Now I'm going to simply combine my like terms. Remember, like terms, as it says on the very top of your paper, says that it has the same variable and the same exponent or power. So here are my variables that match. So I have an m squared here and an m squared here. I will be adding those. I have a regular m here and a regular m here. I'll be adding those. And then you'll see my constants, which have no variables. I have this and this right here. So when I combine my m squareds, I'm just adding, because that's what sum means. This gives me 3m squared. Notice I didn't change that m squared into something different. I didn't add my exponents or anything like that. We don't do that when we combine like terms. Now, here I have a plus 3m and a minus 3m. And when you add those, it goes away. Okay, so think about 3 plus negative 3. If you type that into your calculator, it would go away. If I typed in my calculator negative 4 plus negative 2, that would give me a negative 6. So I'd write that as minus 6. All right, so that's it. That's my answer. Okay, let's try the next one. Again, I'm just going to write these out just right next to each other. Just easier to deal with this way so you can see what I'm doing. Sum means add, which is why I'm adding these. Here my variable that I see is x. I want to combine my x squareds. I want to add my x's. And I want to also add my constants. So negative 3 plus negative 5, this gives me negative 8 x squared. And negative 7 plus 6 gives me a negative 1. You don't have to write the 1 in front of that x. You can if you want. But mathematically, normally in a textbook or something like that, you wouldn't see the 1 in front of the x. So I'm not going to write it. Negative 9 plus negative 4 gives me a positive 5. And that's my answer. All right. So again, this shouldn't be brand new, but that's adding polynomials. You'll get class practice with this. A little bit trickier is subtracting polynomials, and you can see this says keep, change, change. This should sound familiar to you. It's okay if it doesn't. All I'm going to do is rewrite this so we can kind of see what we're working with here. So this is subtraction. I'm still going to be focused on my like terms here. So there's a lot of ways for me to explain this to you. You can think of this like there's a -1 in front of here, and I need to distribute that -1. We've distributed before. Okay, so that's not new, but you can think of this like a -1, and I would have to distribute that -1 to everything that's over here. Remember, when we subtract, we do it in a specific order, so the order matters. It's important that all of this gets multiplied by a -1 and not this. Okay, so it's not whatever you want here. So if I did that, that would look like this. I'll keep this in the group here. I don't have to do that technically, but I like to just so I can keep these polynomials separate. Now, if I multiply a -1 times a positive, that gives me a negative. And if I multiply a -1 by a negative, that gives me a positive. And if I multiply a -1 by a positive, that gives me a negative. Okay? And now I'm just going to combine my like terms again. So I have this x squared here and this x squared here. Notice that that is a negative. I'm actually, at this point, I'm going to be adding these things together because I'm just combining. Okay, so when I do 3x squared minus 6x squared, or you could think of it like 3x squared plus negative 6x squared, that gives me a negative 3x squared. Okay, if I add my xy's together, this gives me 6xy. And then my constants, again, I'm just looking at these, okay? So this is 7 plus -3, or you could think of it as 7 minus 3. Either way, this gives me a positive 4. That's my answer, okay? Now, I'm going to show you this more in a keep, change, change sort of way, okay? Still the same concept. Order matters, okay? So this is very common. So this says if this polynomial is subtracted from, okay? When you see that, we're trying to take this away from this polynomial. So I'm going to write this polynomial first, okay? So and that's really, really important because order matters. So it's really important that I did that, and it's really important that we understand it. So I'm not sure if this will show up, but this one had to go first. Can we see that? Yeah, we can kind of see that. Okay. And then this is going to come second. So if it says subtracted from, put this here. Okay. And this is being taken away from that. Okay. Now, this is the keep, change, change. So this is normally how I like to do this. Rather than like distributing that -1 and writing it down, I just know that what's going to happen if I keep all of this and change that, change this, change this, change this. So what did I do? I just changed all my signs in here, and now I'm going to be adding. Okay, that's pretty much what I did before. So this is a plus here. It was a minus. Now it's a plus. Okay, so now I'm just going to combine my like terms again. So pretty much we're doing what we've been doing. I just want to make sure I can see all my terms. So now this is x squared plus -2x squared, which gives me a negative x squared. Remember, I could put a 1 in there. I suppose I will right now, but normally I would not. If this were like a multiple choice question, they pretty much wouldn't put a 1 there. okay? Now I have 3x plus x, which gives me 4x. And finally, my constants, I have a -2 plus a -6. That would be -8. And that's subtracting polynomials. Okay. The distributive property. So we know about the distributive property, but what we need to remember, which we have not seen yet this year, is we need to remember what happens when you multiply with exponents. And you might remember this from last year. This should sound familiar. When you multiply with exponents, you're supposed to keep the base and add your exponents. Keep the base and add your exponents. All right, so add exponents. Again, though, guys, this only works when we're multiplying, okay? When we multiply, we add the exponents, okay? So this really has an exponent of 1, okay? We just don't typically write it. So when I distribute this, remember, like, distribute means multiply. What happens here is x times 5x gives me a 5x squared. And x times x squared gives me an x to the third. I added my exponents, and that's my answer now. Look at the next one. This gives me a 4x to the third power. I added 1 plus 2. I added these x's. And what I did here is I multiplied. 1 times 4 is 4. Okay, so I am going to multiply my coefficients. Okay, your coefficient, I should have put that in the vocab, sorry. Your coefficient is the number in front of your variable. I believe we saw that in Unit 1. Yeah, we definitely did. All right, moving on. Okay, so now here I have 3x squared. And then finally I have plus 2x. All right. It always looks a little bit scary. For example, number 7, when you see an x and a y, we've got a couple more variables. We have to get used to that. This happens a lot in 9th grade and as you go on through math. So just take your time. -2 times a +2 gives me a -4. This x comes along for the ride, and now I have y squared. All right, so I'm adding my exponents for any of my variables that match here. Okay, so check out the next part. So -2 times 4, that gives me -8. This is going to be x to the third and y. So notice, just because the variables didn't match here, like for example, there was no x here, that doesn't mean x goes away. That's still there. We're multiplying all of this together. Okay? All right. So that's multiplying. Now here we kind of tie it all together a little bit. This is called simplifying a polynomial. So in this first example right here, my first step, if you think about PEMDAS, order of operations kind of thing, I'm going to multiply here. So I guess normally in PEMDAS, I shouldn't have said that. Normally in PEMDAS we would do parentheses first, but I can't combine these. These aren't like terms. Same thing here. So that means that I am going to go ahead and distribute. Okay. So when I distribute, I multiply. This gives me 10a squared minus 35a. That was me distributing for that first part. And now this part, this gives me a minus 3a squared minus 3a. Let's look at that. Let's talk about that. So a negative times a positive, that's why that's a minus, a negative, and a negative times a positive again gives me that. All right, I'm ready to combine my like terms. Look at these a squareds. And we'll use this one. And then we have some a's here. Okay, so this would be like 10 minus 3, so that gives me 7a squared. I'm combining now, so I'm not doing anything with my exponents when I just combine like terms. Okay, and then here, this gives me a minus 38a. All right. Okay, example number 9. The big problem with number 9 is that a lot of kids want to go ahead and add 2 and 4, and that's bad. Do not do that. That is very bad. We need to distribute the 4 first. Okay, you have to. You can't add before you multiply. Okay, so here I have 2 plus 4x minus 28. I multiplied. All I can combine are these constants here. So this 4x is just going to stay just as it is. And this is like 2 minus 28 or 2 plus a negative 28. That should give me minus 26. All right, so that's simplifying polynomials. Again, should not be brand new. Now this might be brand new. You might not have seen this at all before. It's very, very simple. Sometimes you'll be asked what the degree of a polynomial is. And all you have to do is find its largest exponent. Its largest exponent. Remember, the exponent is your power. Okay, so the largest exponent, if I look at all of these here, is 2. Okay, it has a degree of 2. My largest exponent here is 3, so this has a degree of 3. Okay, so this could be a common multiple choice question. It could say, what is the degree of the polynomial? And you might have some choices. Again, when it asks you for degree, you just look for your biggest exponent. That is my biggest exponent, so this is a degree of 3. All right, now example 11 is trying to trick you. What is the degree of the polynomial? You might be tempted to say 4, but if you keep looking, 5 is actually the higher exponent. All right, so my answer here would be 5. This is a degree of 5. So don't get too comfortable here. It's not always the first exponent that you see. You really need to make sure that you look through. All right, and that's everything. So there's no practice for you to do on your own today, but you will have plenty of practice when you get to class. I hope that you enjoyed this video. I hope I didn't go too fast. And we will see you in class. Bye.